Shocking images of Jupiter. What the James Webb Telescope truly saw. Jupiter, the largest planet in our solar system, has long captured the imagination of scientists and astronomers alike. With its tumultuous weather systems, vast atmosphere, and fascinating moons, Jupiter presents both a mystery and a treasure trove of knowledge about the formation of our solar system. But what if we told you that some of the most stunning revelations about this gas giant have only just been uncovered thanks to the James Webb Space Telescope? In this video, we delve into the groundbreaking discoveries made by Webb, from signs of extraterrestrial life on Jupiter to the strange, fluctuating storm of the Great Red Spot, and other surprising features of the planet that are slowly becoming more visible. What is Jupiter hiding, and how has the Webb telescope uncovered its secrets? But before we find out the answer, don't miss a moment of discovery. Subscribe to the UFO Universe channel for more astonishing space revelations and mind-bending cosmic mysteries. Until now, the James Webb Space Telescope, JWST, has not discovered alien life on Jupiter itself, but it has made groundbreaking observations that deepen our understanding of the planet and its moons, particularly Europa, one of Jupiter's most intriguing satellites. In September 2023, the James Webb Space Telescope detected carbon dioxide on Europa, a moon believed to harbour a subsurface ocean beneath its icy crust. What makes this discovery compelling is that the carbon dioxide appears to be native to Europa, not delivered by external sources like meteorites. This suggests that the moon's internal ocean may contain the essential ingredients for life, making it a prime candidate in the search for extraterrestrial biology. The carbon dioxide was found in a geologically young region called Terra Regio, where surface disruptions hint at material exchange between the ocean and the surface. This has given rise to speculation that it is very possible that Jupiter's satellites have the presence of aliens, but we have not been able to detect them. The detection of carbon-based molecules is extremely significant because carbon is a fundamental building block of life as we know it. The James Webb Space Telescope's powerful infrared instruments allowed scientists to identify both crystalline and amorphous forms of carbon dioxide in Europa's chaos regions, where the surface ice appears fractured and mixed. These regions are thought to be areas where the subsurface ocean interacts with the surface, potentially transporting organic materials upward. According to planetary scientist Samantha Trumbo, who led one of the studies published in Science, the concentration of carbon dioxide in these areas strongly suggests an internal origin, reinforcing the idea that Europa's ocean could be chemically rich enough to support microbial life. This discovery adds to previous Hubble Space Telescope findings that indicated the presence of ocean-derived salts in the same region. Otherwise, Jupiter's Great Red Spot, a colossal storm that has raged for centuries, is now showing signs of instability. Recently, it has been observed wobbling and almost trembling, with its size fluctuating in unexpected ways. The storm, once spanning over 24,000 miles, has now shrunk to about 10,000 miles across. Interestingly, it isn't consistently shrinking. Instead, it appears to expand and contract, almost as if it's pulsating. The exact cause of this phenomenon remains unclear. The wobbling motion is truly captivating. It could be linked to the intense jet streams and turbulent swirls surrounding it. Jupiter's atmosphere is a chaotic system, and all that energy might be pushing and pulling the storm in various directions. Additionally, Jupiter produces a massive amount of internal heat, which might also influence the storm's behaviour. Not long ago, there was even an instance where parts of the storm appeared to break off and drift away, leading some to speculate whether the Great Red Spot was being torn apart. However, this storm is fueled by an incredible amount of energy, so it isn't disappearing anytime soon. While its shape or size may shift, it's likely to persist for decades, if not centuries. The recent wobbling and size fluctuations of the Great Red Spot serve as a reminder of Jupiter's dynamic and unpredictable nature. The latest images are revealing even more mysteries about this gas giant. Citizen scientist Judy Schmidt from Modesto, California, used data from the James Webb Space Telescope to process and enhance images of Jupiter, producing stunning results. The images reveal the auroras in striking detail, as well as a small debris ring and several moons orbiting the gas giant. The exceptional clarity of these images has provided new opportunities to study the dynamics of Jupiter in ways previously unimaginable. Jupiter's upper atmosphere serves as a boundary layer between the planet's powerful magnetic field and the various atmospheric layers beneath it. At the poles, the magnificent auroras are powered by volcanic material ejected from Io, one of Jupiter's moons, which will be discussed in more detail shortly. Near the equator, the atmosphere is influenced by sunlight. Although Jupiter receives only about 4% of the sunlight Earth gets, it was once believed that this region would appear relatively uniform. Previously, in July 2022, the James Webb Space Telescope's near-infrared spectrograph examined Jupiter using its Advanced Integral Field Unit, focusing on the region above the Great Red Spot. Scientists aimed to determine whether this area was as uneventful as anticipated. Contrary to expectations, the observations uncovered a surprising array of features, including dark arcs and bright spots scattered throughout. The blue regions in the image represent significantly lower altitudes compared to the red areas, highlighting the storm's intriguing structure. While sunlight plays a role in the light emitted from this region, researchers identified another mechanism influencing the atmospheric composition. One possible explanation involves gravity waves, similar to the ripples created by crashing ocean waves. These waves originate deep within Jupiter's chaotic lower atmosphere, travelling upward and shaping the structure and emissions of the upper atmosphere. Interestingly, such waves occasionally occur on Earth, but are far weaker than the ones observed on Jupiter. Additionally, a previously unknown feature in Jupiter's atmosphere was discovered. A massive white band of clouds, spanning over 3,000 miles wide, was found above the planet's primary cloud deck near the equator. This band moves across the planet at an astonishing speed of 320 miles per hour, far exceeding the strength of even the most intense storms on Earth. Not only is the James Webb Space Telescope capturing incredible images of Jupiter, but let's also remember the Juno probe, which has travelled an impressive 1.7 billion miles and continues its mission around Jupiter. During its 66th flyby of the gas giant, Juno captured stunning new images of the planet and some of its moons. Citizen scientists used publicly available raw image data to enhance the contrast of visible light images, revealing Jupiter's vibrant colours and intricate visual complexity, and showcasing the detailed dynamics of its turbulent atmosphere. These images depict vivid and powerful swirling bands, cloud formations, and vortices, including cyclones and hurricanes of various sizes and intensities. Many images show a series of small cyclonic storms that appear interconnected, suggesting that Jupiter's atmosphere is much more complicated and interconnected than previously believed. Jupiter is shrouded in mystery, and it boasts 79 moons, the largest being Ganymede, also known as Jupiter 3. This Hubble Space Telescope image highlights the immense size of this moon. Ganymede orbits approximately 666,000 miles from Jupiter, and it holds fascination for various reasons. The Juno probe continues to study Jupiter and its moons, recently capturing new images of Ganymede. These were the first photos of the moon in 20 years, revealing surprising findings. Upon reviewing the images, scientists discovered evidence suggesting that Ganymede was struck by an asteroid nearly 93 meters wide around 4 billion years ago. This massive space rock was about 10 to 15 times larger than the Chicxulub meteor that hit Earth 66 million years ago. The impact was so forceful that it knocked Ganymede off its axis and altered its rotation. Interestingly, most of the material from the collision fell back into the crater, leaving it largely concealed. Nonetheless, the evidence of this tremendous impact remains visible on the moon's surface. Ganymede has numerous craters, some of which are quite large, indicating that the Moon has been struck by more than one massive asteroid in its ancient past. However, Ganymede may be concealing more than just its cratered surface. It could be hiding something much deeper. Recent discoveries have revealed that water vapor exists in the Moon's thin atmosphere despite being located 500 million miles from the Sun. The surface ice of Ganymede is frozen solid, with temperatures plunging as low as -300 degrees Fahrenheit, making it as hard as rock. Yet, a constant rain of charged particles from the Sun is still enough to transform the ice into water vapor. Although Ganymede may seem like an ordinary, lifeless, icy moon, some scientists speculate that beneath its frozen exterior lies a vast ocean of liquid water. If this ocean exists, it could harbour life or provide valuable insights into the conditions needed for life to develop. Upcoming missions are planned to explore what lies beneath its icy crust. Next up, one of Jupiter's most intriguing moons is Io, which does far more than merely orbit the planet. This leads us to the topic of auroras. On Earth, auroras are caused by charged particles from the Sun colliding with our atmosphere, but Jupiter's auroras are entirely different. Being much farther from the Sun, scientists were initially puzzled about the source of energy powering Jupiter's auroras. During a flyby of Jupiter's poles, the Juno spacecraft detected electrons in the planet's atmosphere, being driven toward it with energies reaching up to 400,000 electron volts, an incredible 30 times stronger than the most intense auroral potentials ever recorded on Earth. A time-lapse image also revealed a fascinating phenomenon: emissions associated with the magnetic footprints of 3 of Jupiter's largest moons. These footprints map the path of Jupiter's magnetic field from each moon down to the planet's surface. The glowing emissions are the result of electric currents produced by the moons, which travel along Jupiter's magnetic field and interact with its upper atmosphere. This discovery is significant, as its importance will soon become clear. Io is blanketed with lava lakes and hosts over 400 active volcanoes that continuously eject volcanic material into Jupiter's magnetosphere. In a captured image from the Juno probe, 2 plumes from Io's active volcanoes are visible, and recent Juno data revealed a massive volcanic eruption. By analysing these new images and combining them with data from the Juno probe's instruments, scientists discovered that Jupiter emits bursts of X-rays every 27 minutes. Researchers then examined the Juno data to identify what other events coincided with this interval. It was found that as Jupiter rotates, it pulls its magnetic field along, which is directly impacted by solar wind particles, causing compression. This compression heats ions, which are electrically charged atoms trapped in Jupiter's magnetic field, and initiates a phenomenon known as electromagnetic ion cyclotron waves. Guided by Jupiter's immense magnetic field, ions ride the emic wave and ultimately collide with the planet's poles, producing the stunning X-ray auroras captured in images. However, these auroras are powered by more than just this phenomenon. Io, orbiting 262,000 miles from Jupiter, intersects the planet's strong magnetic force lines, effectively transforming into an electric generator capable of producing 400,000 volts and generating an electric current of 3 million amps. Naturally, this current follows the path of least resistance along Jupiter's magnetic field lines, reaching the planet's surface and resulting in lightning and auroras in its upper atmosphere. Decades of in-depth research have revealed the extraordinary complexity of Jupiter. Recently, scientists discovered 12 additional moons orbiting the gas giant, bringing the total count of its satellites to 92, more than any other planet in the solar system. The newly identified moons range in size from 1 to 3.2 kilometers. Most of them have distant orbits, with 9 out of the 12 taking more than 550 days to complete a single revolution around Jupiter. Researchers suspect that these outer moons, which move in the opposite direction to Jupiter's rotation, may be captured asteroids. It is widely believed that Jupiter serves as a protective barrier, shielding Earth from potential cosmic threats. Astronomers have previously proposed that that Jupiter may have been instrumental in giving life a chance to evolve on Earth. However, recent discoveries have raised questions about Jupiter's role as Earth's cosmic protector. Long-period comets, originating from the farthest reaches of the solar system and taking thousands of years to complete their orbits around the Sun, occasionally venture into our solar neighbourhood. Jupiter's powerful gravitational pull often deflects these fast-moving icy bodies, ejecting them from the solar system before they can come close to Earth. As a result, collisions with long-period comets are exceedingly rare, occurring only over millions or even tens of millions of years. Jupiter's presence is critical in reducing the likelihood of such impacts. That said, Jupiter's gravitational influence has both protective and hazardous effects on Earth. On the positive side, its massive gravity prevented nearby space debris from coalescing into a planet, leading to the formation of the asteroid belt, a region filled with countless fragments of rock and ice between Mars and Jupiter. On the downside, Jupiter's gravitational forces continue to alter the trajectories of some asteroids, sending them closer to the Sun and increasing the probability of collisions with Earth. This phenomenon has already been observed in Earth's history. In 1770, Lex's comet came astonishingly close to Earth, passing within just 1 million miles, an incredibly short distance on an astronomical scale. Experts believe the comet originated from the outer edges of the solar system and was redirected toward Earth after a near encounter with Jupiter. Following 2 orbits around the Sun, the comet returned to Jupiter's vicinity 9 years later, where the gas giant's gravitational influence expelled it from the solar system. The Jupiter shield theory, backed by earlier computer models, proposed that Jupiter frequently ejects long-period comets from the solar system. This theory even anticipated the collision of the comet Shoemaker-Levy 9 with Jupiter in 1994. However, computational tools at the time were far less advanced, requiring extensive manual calculations. Today, with improved data and technology, scientists observe a higher number of short-period comets and near-Earth asteroids crossing Earth's orbit compared to long-period comets, and updated simulations present a new perspective. Jupiter's powerful gravitational influence interacts with the asteroid belt, creating gravitational resonances that eliminate stray asteroids and redirect them inward. Collisions between asteroids further contribute to this process by scattering rocky debris into resonant zones. The inner boundary of the asteroid belt is particularly impacted by a phenomenon called secular resonance, which propels material toward the inner solar system. Jupiter's massive size enables it to both redirect comets toward Earth, such as Lex's comet, and eject them from the solar system entirely. If Jupiter's mass were reduced to just 1/10 of its current size, it would still destabilize comets, but would lose much of its ability to remove them, resulting in a higher frequency of impacts on Earth. The rate of impacts significantly influences the long-term evolution of life on a planet. Geological evidence from Earth suggests that a major collision, roughly every 100 million years, allows sufficient time for the biosphere to recover and flourish. Conversely, a much higher impact rate, occurring every few million years, could cause catastrophic damage to the planet, severely hindering the formation of a stable biosphere. Some scientists suggest that collisions with Earth may have been responsible for bringing water to our planet. But what about water on Jupiter? Water vapor was first detected on Jupiter in 1995, a discovery made by the Galileo spacecraft, which conducted detailed observations and measurements of the planet and its moons. The spacecraft's instruments, particularly the near-infrared mapping spectrometer, detected water vapor in Jupiter's atmosphere during a close flyby. However, recent data shows that water makes up about 0.25% of Jupiter's atmosphere above the planet's equator. While this might seem like a small amount, it actually represents a massive quantity of water. As one of the first planets to form in our solar system, Jupiter holds a substantial amount of gas and dust that never became part of the Sun. Understanding the amount of water present on Jupiter is crucial for scientists studying the formation of our solar system, and also the sign of extraterrestrial life. In recent years, researchers analysing telescope data have uncovered a significant presence of water within Jupiter's iconic Great Red Spot. NASA's Juno spacecraft, launched in 2012, continues to orbit the massive gas giant, capturing detailed images of its cloud formations. Equipped with cutting-edge instruments, Juno has provided further evidence of water on Jupiter. Given that this colossal planet possesses more than twice the combined mass of all other planets in the solar system, even a small proportion of water would equate to a vast amount, far surpassing the water found on Earth. Water in Jupiter's atmosphere also explains the planet's stunning lightning displays, which are 100 times brighter than those on Earth, as well as its unique hailstones. Lightning has previously been observed in Jupiter's water clouds, where water droplets collide with electrically charged ice crystals. However, Juno has also detected faint lightning at higher altitudes in the atmosphere, where temperatures plummet to around -87 degrees Celsius, too cold for liquid water to exist. So, how does lightning occur under these extreme conditions? The answer is in ammonia, an extraordinary component in Jupiter's atmosphere that acts as a natural antifreeze. In the upper atmosphere, water ice crystals merge with ammonia vapors and melt. These ammonia water droplets then interact with additional ice crystals rising from lower layers, producing an electrical charge that results in lightning. Beneath the ammonia ice clouds, the ammonia water droplets continue to grow until they become too heavy to stay airborne, eventually forming hailstones similar to those found on Earth. Scientists theorize that these mushball-like hailstones sink deeper into Jupiter's atmosphere. However, venturing further into Jupiter's inner layers reveals even more intriguing mysteries. For a long time, it was widely accepted that the giant planets of our solar system had rocky cores. Recently, though, this theory has been called into question. By analysing data from Juno's orbital mission, researchers are investigating how matter is distributed within Jupiter, uncovering an unexpected enigma at the heart of the gas giant. Jupiter's core experiences pressures far greater than those on Earth, and temperatures reaching an astonishing 20,000 degrees Celsius. To replicate these extreme conditions, scientists employ high-powered lasers to compress materials in laboratory settings, simulating the planet's pressures. The Center for Matter of Atomic Pressures at the University of Rochester leads this cutting-edge research. The density of materials in Jupiter's core varies depending on their composition and physical characteristics. Scientists have recently uncovered that Jupiter's core is less compact than previously believed. Only about 18% of its inner material is rocky. The planet is primarily composed of hydrogen, which makes up around 90% of its makeup, along with approximately 10% helium and trace amounts of other elements. In its outer layers, hydrogen exists as a colourless, transparent gas, similar to how it appears on Earth. However, as you move deeper into Jupiter, the rising atmospheric pressure causes hydrogen to transform into a dense, metallic-like fluid capable of conducting electricity. What exactly is this substance? Roughly 10% of the way toward Jupiter's core, the immense pressure compresses the hydrogen gas into a rare state called liquid metallic hydrogen. This unique form of hydrogen has properties akin to water, with low viscosity, excellent electrical conductivity, and high thermal conduction. Within Jupiter, this abundant material turns the planet into an enormous natural generator. On Earth, elements can exist as solids, liquids, or gases, relying on the surrounding temperature and pressure. Hydrogen, which is usually a gas on our planet, can be artificially compressed and cooled to transform into a liquid or solid. Even in these forms, hydrogen remains non-metallic, exhibiting poor conductivity for heat and electricity. In contrast, metals are highly efficient at conducting heat and electricity due to their atomic structure. However, under the extreme temperature and pressure conditions within the gas giants of our solar system, hydrogen can transform into unique states, such as liquid metallic hydrogen. In these extreme environments, hydrogen atoms lose their electrons, creating a mixture of free-floating hydrogen nuclei and electrons. This electron mobility mimics the conductive properties of metals. Some theories suggest that Jupiter's core could be composed of vast oceans of this exotic substance. Based on estimates of the Jovian core's mass, it may be 12 to 45 times heavier than Earth. A 4,000 kilometer thick layer of liquid metallic hydrogen, combined with Jupiter's rapid rotation of approximately 10 hours, produces an immense magnetic field, extending up to 725 million kilometers. This magnetic field is the largest in the solar system and holds many unresolved mysteries. Scientists have delved over 320 kilometers into Jupiter's atmosphere and discovered a newly identified region called the Great Blue Spot, which is distinct from the planet's iconic Great Red Spot storm. While it was already known that Jupiter's magnetic field is complex, researchers were surprised by just how unusual it truly is, with the Great Blue Spot playing a significant role. Jupiter's magnetic field is 20,000 times stronger than Earth's, but scientists have now found that its strength is highly variable. Unlike Earth's dipolar magnetic field, Jupiter's magnetic field emerges from a broad area in the northern hemisphere and re-enters near the South Pole. Additionally, researchers have pinpointed a concentrated magnetic region just south of the equator. The Great Blue Spot, situated near the equator, acts almost like a secondary Jovian South Pole. The massive storm that has persisted for centuries is likely fueled by high concentrations of ammonia in the atmosphere. The intensity of the magnetic field at the Great Blue Spot fluctuates by up to 1% annually, strengthening and weakening in various areas. By the conclusion of NASA's extended Juno mission in 2025, scientists are expected to gather sufficient evidence to test their theories. As investigations progress, new mysteries about this gas giant are bound to emerge. The Great Blue Spot and the Great Red Spot share the same latitude, suggesting a potential connection between the two phenomena. Gas giants are generally known for their elevated temperatures, particularly in their upper atmospheres. In our solar system, the two prominent gas giants are Saturn and Jupiter. However, Jupiter does not maintain consistently high temperatures throughout its entire structure. Renowned as the largest planet in the solar system, Jupiter is famous for its colossal storm, the Great Red Spot, which is twice the size of Earth. Yet, this gas giant also features other notable spots. The Great Cold Spot is nearly as vast, and scientists have been studying this phenomenon for years. Currently, at its largest, the spot spans approximately 12,000 by 24,000 kilometers. Unlike the renowned Great Red Spot, this fascinating atmospheric feature is characterized by significantly cooler temperatures, around 200 degrees colder than its surrounding atmosphere. The Great Cold Spot is highly dynamic, frequently vanishing and reappearing. Researchers have determined that its recurrence is linked to Jupiter's auroras. Due to this connection, the spot's age aligns closely with the age of the planet's polar lights, which dates back thousands of years. Similar to Earth's auroras, Jupiter's are caused by charged particles interacting with the atmosphere near its poles. However, Jupiter's polar lights are more stable and intense, fueled by particles originating both from its moons and the Sun. Recent discoveries reveal that Jupiter's auroras deliver energy into the planet's atmosphere, causing a noticeable temperature difference between its upper and lower layers. This temperature variation leads to the development of a swirling vortex, forming a cooler region that stands out from both the aurora itself and the surrounding atmosphere. Earth experiences similar phenomena, but due to differences like Jupiter's rapid rotation, which helps trap heat in certain regions, and the unpredictable nature of these events, polar lights on Earth tend to be less consistent and more irregular in comparison. Not only that, a surprising discovery about Jupiter reveals that, contrary to popular belief, the gas giant does not actually orbit the Sun. Instead, the center of gravity, or barycenter, between Jupiter and the Sun lies outside the Sun's surface, at a specific point in space. This means that both Jupiter and the Sun orbit around this shared center of gravity. For comparison, consider the Earth and the Sun. In this case, the center of gravity is so close to the Sun's core that its effect is almost imperceptible. The Sun appears stationary, while the Earth follows a seemingly perfect circular orbit. A similar phenomenon occurs with the International Space Station, ISS, and Earth. Both the ISS and Earth revolve around their shared center of gravity, though Earth appears motionless while the ISS seems to orbit it in perfect circles. This principle applies to most planets in our solar system. Even Saturn exerts minimal influence on the Sun's position in space. Nevertheless, when the mass difference between two objects decreases, the dynamics change. Jupiter's massive size shifts the barycenter to a point 1.07 solar radii away from the Sun's center, or roughly 7% of a solar radius above its surface. As a result, both Jupiter and the Sun revolve around this specific point in space. Our ancestors were aware of Jupiter's immense size. The gas giant's mass is 2.5 times greater than the combined mass of all the other planets in the solar system, and a staggering 3,177.8 times the mass of Earth. Its volume is also 1,300 times larger than that of our planet. However, with modern advancements in technology, we now know far more about Jupiter beyond its sheer size and mass. Astronomers closely study the gas giant because Earth's future is intricately connected to it. Recent findings indicate that something unusual is currently occurring on Jupiter. Often referred to as the super vacuum cleaner of the solar system, Jupiter's immense gravity and position in the inner solar system make it a natural shield. Over time, it has absorbed significant asteroid impacts that could have otherwise struck Earth, such as the collision with Shoemaker-Levy 9 in 1994, when the comet fragmented and crashed into Jupiter. So, what's the unusual occurrence happening with Jupiter? Its most iconic storm, the Great Red Spot, appears to be shrinking, and scientists are uncertain about how this will impact the planet. The Great Red Spot is an enormous anticyclonic storm on Jupiter. While the largest storms on Earth can span over 1,600 kilometers, with wind speeds reaching up to 320 kilometers per hour, they are dwarfed by the Great Red Spot, which measures around 16,000 kilometers in diameter and has winds swirling at 650 kilometers per hour. Astronomers first observed the Great Red Spot in the 17th century, and it continues to captivate scientists today. The storm's striking reddish hue has long been a puzzle. Some researchers theorize that its color comes from complex organic compounds being drawn from Jupiter's interior into the upper atmosphere. Others suggest the reddish tint is caused by sunlight breaking down various chemicals in the storm's upper layers. If this theory is correct, the storm itself may not be very red, and what we see could simply be a sunburned effect on its surface. And this is the end of today's episode, and we truly appreciate you being here. If the stories, evidence, or theories you heard today made you think twice about life beyond Earth, please like the video and subscribe to the UFO Universe channel. We have more incredible investigations and discoveries coming soon. Don't miss out. Join the growing community of truth seekers.